So, dear friends, today we are going to start with the concept of set, the basic thing that we require in mathematics. So, we need to understand what is set. So, set is actually the collection of well defined, well ordered elements. So, what we can have is this is the collection of well defined objects. Yeah, so for example, what we can have the set, we can have the set of all alphabets. We can have the set of all digits. Now, we need to understand the cardinality of the set. So, what we have, the cardinality of set. So, the cardinality of the set means the number of element in a set. For example, if I consider S be a set of all alphabets, then we can have the cardinality. Cardinality is denoted by n of S is equal to 26. We have 26 alphabets. Then if I consider R the set of all digits, then we can have the cardinality of R is equal to 10. What are these 10 digits? These 10 digits are 0, 1, 2 up to 9. So this way the cardinality of set R is going to be 10. Now we consider the Cartesian product of two set. So how to define a product of sets? So we have, let A be a set with two elements, that is A is equal to A and B. Now we consider the another set. So let B be a set with three elements. That is, if I consider the set B is equal to 1, 2, 3. Now we define the product of these two sets. So consider the product of these two sets A cross B is the collection of all elements or all the pairs of the type x comma y, where x belongs to the set A and y belongs to the set B. Now we'll write the elements of this A cross B. So we can collect all such pairs. So if I consider element from set A, then y is the element set from the set B. So I can have a pair A1, I can have a pair A2, I can have a pair A3. Now if I consider this element B from set A, then I can have a pair B1, I can have a pair B2, I can have a pair B3, and these are only the possible pairs. So we get A cross B is equal to the set of all pairs. Important thing is this all pairs are ordered. The first element is always from set A and the second element is always from set B. Now we have defined the product of two sets. Now we consider the relation on these two sets. So we have, let A be a set AB and B be the another set 1, 2 and 3, and we have a product of these two sets, that is A cross B is A1, A2, A3 and B1, B2, B3. Now we need to define the relation. So let R be the relation from set A to set B if R is subset of A cross B. Now let us see. For example, if I consider R1 is equal to, so I have this relation. Then I'll define the another set of collection. See, out of these two collections, which is going to be the relation? So if I consider the first set, I have A1 element present in A cross B, B1 element present in A cross B, and B3 element present in A cross B. So we can say this is the subset of A cross B, and if it is a subset of A cross B, this is going to be the relation. So we have R1 is a relation from the set A to the set B. Now we consider the collection R2. So if I consider the collection R2, the element A2 is present in set A cross B. If I consider the element A3 is present in the collection A cross B. And now if I consider 1 comma B, so do we have any element 1 comma B here? No, we don't have. We have the element B comma 1, but here in this collection we have the element 1 comma B, and in cross product the order is fixed. So that's why this element 1 comma B is not same as B comma 1, and hence this element is not in A cross B. So this is not a subset of A cross B, and hence R1 is a relation on A comma A cross B, but R2 is not a relation. Now we have defined the relation. Let us define the function. So we need to understand what is function. See, a function is a special type of relation. Suppose we have two non-empty sets. So let A and B be two non-empty sets. Then we can define a function. So the function f from A to B is a relation which gives the correspondence between the elements of A and elements of B, such that the every element of A corresponds to a unique element of B. So if I consider any element in A, I must have a unique element in B, and if this condition is satisfied, then we say f is a relation which is function from A to B. Now we consider some examples of the relations which are functions. So for example, if I have a set A, so I have A and B, and if I have a set B with the elements 1, 2, 3. Now if I consider the element A corresponds to 1, B corresponds to 1. So what we get here is the element A is corresponding to a unique element 1, B is also corresponding to a unique element 1. So this relation f is a function from A to B. Now I consider the another example. So we have the elements of A and elements of B. Now if I consider the relation where A is related to 1, A is related to 2, B is related to 3. Here this relation gives the relation for A as 1 and A relates to 2 also. So here this A does not relate to unique element because A is related to two different elements, and that's why this is a relation but not a function. So if I consider this relation G, then it is not a function because it does not correspond the element of A to a unique element of B. Now we consider the another example where we have the elements of A and we have the elements of B. So if I consider this relation which relates the element A to element 1, the element B to element 2. Now here we have again a unique correspondence. This element A corresponds to a unique element in B. This element B of A is corresponding to a unique element 2 in B, and that's why this is again a function.